I need to make several cuts in this sheet, but they're not turning out well. So I had an idea. As many of you know, I make griddles and I use a large sheet, 3 millimeters thick. And cutting them is very tedious for me, and I can't get the cut straight, and I end up with a lot of back pain. So I came up with the idea to make a machine to help me cut. The first thing I do is cut this 60x50 structural pipe. I'm going to mark it at 1800 millimeters. That's 1 meter 80. Something I always recommend, before cutting, measure twice. Even though it might seem obvious, it's essential to be sure about the cut. That guarantees your cuts will be perfect and you won't have to go back and fix them later. Once I have the pipe cut, before welding the frame or the structure, I'm going to check that it's properly squared. For that, I measure the diagonals. That's why I only welded on the outside. If it happens to be a little crooked like this, I still have room to square it up when I check that the diagonals match and the frame is perfectly squared. Then I weld on the inside and make everything firm. Now I move on to the arches. I'm going to use 30 by 30 pipes and make 2 identical arches. First I make one and then use it as a mold to make the second one, so they turn out identical. Each small arch is 25 by 35 centimeters. Once they're welded, I place them together. I mark a line and drill them with a 10 millimeter bit. These holes have to go all the way through so they line up properly later. When assembling, I place the first arch 10 centimeters from the edge of the main pipe and mark the position of the second one. Before placement, I drill the 60x50 pipe 1800 millimeters long with a 10 millimeter bit at each point. This way, when you assemble them, the holes will line up perfectly and everything will be centered. I've already received the products I ordered from JLCMC, and honestly, the shipping was super fast. I had the package in my workshop in just 4 days. Look how neat it comes. Everything is packaged. Here are the clamps and the quality is excellent. I ordered several sizes because I know they'll be useful for future projects and videos. Lastly, these wheels I'll use in another project are large and heavy. Impressive. I couldn't find this model anywhere, but at JLCMC I found it without any problem. They're also height adjustable. Honestly, excellent products. Then I use a 19x 13 centimeter sheet as a guide, and I use a piece of the same 60x50 pipe that I had left over. On this sheet, I'm going to place a 6001 bearing 1 on each end. I carefully mark the spot and drill with a 12.5 millimeter bit. I have another sheet just like it, so I use the first one as a template for the second, so that all 4 holes are aligned in the center. I also make some openings to house the bearings. To secure the bearings, I use this box of screws from the brand JLCMC. It's fantastic because it comes with its own Allen keys and a huge number of screws. It has 1,750 pieces and costs under $6. Honestly, it's a great price for what it offers. From there, I take some 6 millimeter screws to secure the bearings in place. Now I'm going to assemble the system that will make the cart move. For that, I'm going to use a 1/2-inch threaded rod. Since my table is 1,800 millimeters long, I would need a 2-meter rod, but I couldn't find one. I'm not even sure if that size exists, so I'm going to join two 1-meter rods together. What I do is sharpen the tip of both rods and weld them together to make a single one. To ensure the joint is straight and has the same thread pitch, I cut it. A 1/2-inch nut in the middle, a full nut, then the half nut, and finally another full nut on the other side with that half nut in the center. It serves as a guide to keep perfect alignment and a continuous thread pitch. After welding, I use a 1/2-inch die on the joint to clean the thread, so the nut moves smoothly and doesn't get stuck. Finally, I use a perforated flat bar along with a bearing with a 1/2-inch inner diameter so the threaded rod can spin freely. I also weld 3 nuts that will help me generate the movement of the carriage. And with that, I have the system ready to assemble the whole set. Now I'm going to assemble the system that will give it height adjustment. For that, I'm going to use a threaded rod with 2 bearings, one on each end, and I'm going to weld all of this onto a metal plate. I know it's not recommended to weld bearings because they can get damaged, but it's what I have on hand right now, and for the use I'm going to give it, it will work fine. Here's how the piece looks after welding. Next, I'll place another sheet on top and weld it to the nut I attached to the brackets. Because if you talk about seasons, tariffs, it was very completo el juego que tenía el sistema. Thought out, especially knowing, pero con estas arandelas quedó perfecto. I like to send, to confront voices. It's sweaty, it's thoughtful, tariffs, hyper yes, defense goes. Thank you. As you can see, to give it the tilt, I welded a hinge to it. This hinge is going to be temporary. They usually have some play, but I want the system to be more precise later, with no looseness. I also cut a 25 centimeter flat bar, made 2 10 millimeter holes, one at each end, and joined them together with the grinder. This will work as a lock to adjust the angle of the grinder. To cover the electronic part, I'm going to use this sheet metal, which is actually covers from clipboards that I make myself. So I'm going to use them to make the cover for the electronic compartment. I'm going to weld them together to cover the whole surface. I'm going to take apart this broken cordless drill, which doesn't tighten properly, and reuse it for this machine. Once I remove the button panel, I cut off the lower part of the drill and leave only the part that holds the motor, with a piece cut from a clipboard cover. I'm going to make the support for the drill motor. For the electronic part, I'm going to use a 12-volt 30-amp power supply along with a 12-volt controller that has reverse rotation and a speed regulator for a direct current motor. To hold the sheet metal or plate that I'm going to cut, I'm going to use these pressure levers with a vertical handle that I got from JLCMC. I ran out of copper-coated wire, so now I'm going to weld with flux. With a flat bar, I made a kind of U-shape that welds the pressure levers. This is what gives movement to the system and allows me to adjust different sheet metal widths. I've finished the cut and look how neat it turned out, straight and clean. Now I'm going to try marking the sheet so I can bend it at 90 degrees. As you can see, once marked, it bends easily and stays at 90 degrees with no effort.